Fire is one of humanity's oldest companions, and one of its most dangerous adversaries. As cities grow taller and more technologically complex, the threat posed by fire becomes increasingly critical. It is no longer enough to rely on instinct and handheld extinguishers. The modern world demands intelligent, integrated, and proactive systems designed to protect life, property, and mission-critical operations from the destructive force of fire. A fire protection system is exactly that, a carefully engineered combination of technology, construction, and procedure designed to detect, control, suppress, and extinguish fires before they grow beyond control. It is not a singular device or tool, but a comprehensive network of components that work together to minimize risk and maximize safety. At its core, a fire protection system serves three primary objectives: life safety, property protection, and operational continuity. Life safety focuses on ensuring that building occupants have early warning and safe routes for evacuation. Property protection involves controlling or extinguishing the fire before it causes significant structural damage. Business or operational continuity is often overlooked but critical. In high-value facilities such as hospitals, airports, data centers, and manufacturing plants, even a few minutes of fire-induced downtime can lead to enormous losses. Thus, the modern fire protection strategy doesn't just fight fire, it fights its consequences. Fire protection systems are typically divided into two broad categories: active fire protection (AFP) and passive fire protection (PFP). Active systems are dynamic and reactive. They respond to a fire by detecting it and triggering suppression or alerting mechanisms. These include fire alarm systems, sprinkler systems, gas suppression systems, and portable fire extinguishers. Fire alarm systems are often the first line of defense. They use smoke, heat, or flame detectors to identify a potential fire and send a signal to a central control panel. This, in turn, activates audible and visual alarms to alert occupants. Sprinkler systems, arguably the most recognized form of active protection, release water upon detecting a predefined heat level, effectively controlling or extinguishing the fire. In specialized environments where water could cause more harm, such as data centers or museums, clean agent suppression systems like FM200 or inert gases are used. These systems suffocate the fire without damaging sensitive equipment. Fire extinguishers, though manual, remain vital. Available in multiple classes: A for combustibles, B for flammable liquids, C for electrical fires, D for metals, and K for cooking oils, they allow trained personnel to intervene before the fire grows. In contrast, passive fire protection is structural and preventative. It involves using fire-resistant materials and compartmentalization techniques to prevent fire and smoke from spreading. These systems don't require activation, they function by virtue of their design and placement. Examples include fire-rated walls, floors, ceilings, and doors that resist fire penetration for up to 4 hours. Fire dampers and ventilation ducts shut automatically to block fire and smoke. Fire-stopping compounds seal gaps and penetrations caused by electrical, plumbing, or communication systems, maintaining the integrity of fire-resistant barriers. Passive systems are often underestimated, yet they play a critical role in slowing the spread of fire and giving active systems and first responders the time they need to act. Designing an effective fire protection system is a specialized task that involves more than just equipment selection. It begins with a thorough risk assessment, taking into account the building type, occupancy load, material hazards, and applicable fire codes. This is followed by layout planning, hydraulic calculations for water-based systems, and the integration of all components into a single cohesive strategy. Modern buildings also require fire systems to work in tandem with HVAC systems, building management systems, BMS, access control, and emergency lighting. The coordination between all these systems is essential to ensure that fire protection doesn't become a source of confusion during emergencies. For instance, the smoke exhaust system must not conflict with pressurization fans, and emergency lighting must remain operational even when power is disrupted. As we move deeper into the 21st century, fire protection is becoming smarter. Technologies such as Internet of Things, IoT, artificial intelligence, AI, and cloud-based monitoring are revolutionizing the industry. Today's fire alarm control panels can send real-time alerts to building managers via mobile apps. Wireless fire detection systems are making retrofits in heritage buildings or remote areas easier than ever. AI-enabled video surveillance can identify flame patterns or smoke before traditional detectors react. Drones are now used in industrial complexes to monitor inaccessible zones for fire threats. Meanwhile, building information modeling, BIM, and digital twins allow designers and engineers to simulate fire scenarios in virtual environments, optimizing the fire protection layout before construction even begins. These innovations enhance detection, reduce response times, and allow predictive maintenance, making fire safety more proactive than reactive. Global compliance is also an essential element of fire protection system design. Engineers must navigate through a labyrinth of international and local codes, such as those from the National Fire Protection Association, NFPA, the International Building Code, IBC, the British Standards, BSEN, and the National Building Code of India, NBC. In Nepal, where my own work is based, engineers frequently adapt standards from both Indian and NFPA guidelines, considering local infrastructure realities and climate conditions. A successful fire protection system doesn't just meet code, it goes beyond, addressing site-specific challenges and user behavior patterns. The effectiveness of any fire protection system also hinges on regular testing, maintenance, and training. A well-designed sprinkler system that hasn't been tested in 10 years is worse than no system at all. It provides a false sense of security. Fire drills, emergency response training, and routine inspections should be part of every building's annual safety plan. Moreover, involving occupants in fire preparedness, especially in educational institutions, hospitals, and high-rise residential buildings, can significantly reduce panic and injury during real emergencies. Training empowers people to respond appropriately, use extinguishers confidently, and follow evacuation procedures calmly. Fire protection is ultimately a combination of science, engineering, psychology, and public responsibility. It is about understanding how fire behaves, predicting how it spreads, engineering systems to respond effectively, and educating people to act decisively. The best systems are invisible most of the time, quietly standing guard until they are needed. They are not just about metal pipes and detectors, they represent our commitment to protecting human life and preserving the built environment. As a fire protection specialist, I often tell clients and students alike, you don't build fire systems because you expect a fire, you build them because you cannot afford not to be ready. The consequences of poor fire planning are not limited to property loss. They include injuries, fatalities, business shutdowns, legal action, and reputational damage. In today's world, fire protection is not a luxury, it is an ethical, economic, and legal necessity. In conclusion, a fire protection system is a holistic approach to safety that combines active and passive strategies to mitigate fire risks. It encompasses detection, suppression, containment, and evacuation, all working together under the guidance of codes, technology, and human responsibility. Whether you're a building owner, engineer, student, or policymaker, understanding fire protection is no longer optional. It is essential knowledge in the effort to build safer, smarter, and more resilient communities.